There's many types of bonding. There's hydrogen bonding, ionic bonding, covalent bonding, and metallic bonding.
Hydrogen bond is a bond where the positive hydrogen pole of a molecule attaches to a negative pole of another molecule, thus linking them together. We note that these bonds are not very strong and therefore only last for a short amount of time.
If the difference of electronegativity is bigger than 2, it means that the bonding is ionic. The positive ion gives away one electron, while the negative ion takes it.
Covalent bonding is when two atoms share a pair of electrons. This can be polar or nonpolar, depending on the electronegativity of the two atoms.
Electronegativity is the ability of an atom to retain electrons. Usually nonmetals have a stronger electronegativity than metals. That's because it's easier for them to achieve the octet rule by taking in atoms.
Electronegativity decides whether a bond will be covalent or ionic. If the electronegativity is less than 0.5, then the bond will be nonpolar, pure covalent. If the electronegativity difference is going to be less than 2 but bigger than 0.5, then it's going to be a polar covalent. If the electronegativity difference is bigger than 2, then the bond is going to be ionic.
London forces are intermolecular forces. They are attractive forces between all atoms and molecules caused by uneven electrons. Electrons from one molecule will be attracted to the nucleus of another molecule. They are weaker than hydrogen bonds. That's why alcohol boils before water.
A dipole is a molecule in which there are two small poles because of the difference in electronegativity between two sides of the molecule. An example of this is dichloroethene, where the electronegativity is stronger on the chlorine side than on the hydrogen side. Those molecules have the so-called dipoles and can attract each other because of that.
Polar solutions mix with polar solutions, and nonpolar solutions mix with nonpolar solutions. They don't mix with each other. That's why water does not mix with oil. On the other hand, aggregators can mix with both polar and nonpolar. That's because the nonpolar tails point outside when in a nonpolar solution, but the polar heads point outside when in a polar solution. For this experiment, we had 7 test tubes filled with water, which as we know is polar, and we mixed different polar and nonpolar substances in it to see if it's separated into 2 layers. The first one was ethanol, which is also slightly polar. It turns out that it does mix with water. The second experiment was with propanol. Propanol is also slightly polar, although not very much. But thanks to its polar property, it also mixed with water. The third one was butanol, which was a nonpolar. This made so that it separated into forming 2 layers, one layer of water and one layer of butanol. The fourth one was pentanol, which just like butanol formed 2 layers because it's a nonpolar. Next up was heptane. Heptane also turned out to be hydrophobic and separated in 2 layers. After heptane we had to mix 2 common items in water. One was food oil and the other was sugar. Sugar, as we all know, mixed with water because it's hydrophilic. But food oil separated and made bubbles of fat. After mixing stuff with water, we had to mix ethanol and heptane together. Ethanol is not a very strong polar, but it's still a polar, while heptane is a nonpolar. They didn't mix together, but it was a cloudy solution. For the last experiment, we had to mix ethanol, food oil, and water. Now all of them have different polarities. Food water is nonpolar, water is polar, and ethanol is slightly polar. So they separated into 3 different layers. In conclusion, this test proves that a nonpolar and polar solution don't mix together, so they form 2 layers, while polar and nonpolar mix